Hello. So let's talk about strong acids and bases and their weak acids, and by comparison, weak bases. So, what is a strong acid, and by reference, what is a strong base? Uh, Base. And in our context, it is something that dissociates completely. That when it is reacting, there is no way for it to go backwards into the equation. So an example of something like this is HCl. And it is not that it can't go backwards, it's just that it is so prone and so far into the realm of into the into reacting for its product side that it is extremely hard for it to react in the other direction, which is why when we calculate KPA, which I'll talk about in our next video, uh, of why a strong acids and bases are a thing. So it dissociates. So what it is something that disassociates completely. A good example of this is hydrochloric acid, and in this reaction, it just forms hydronium ions uh, and chlorine. And here is the list of the seven most popular strong acids. This is very useful. It's hydrochloric acid, and bro, hydro, bro, hydrochloric, hydrobromic, if I'm all of those. The sulfuric acid is number five. Um, uh, what's that one? Um, Nitric acid is four, and yes, and how you could remember these is that the last two, HClO4. If you remember HClO4, remember if it loses an oxygen, it's still a strong acid that stays. With sulfuric acid, H2SO4, eh, this is a little memorization game, and it makes it easier because on papers you really don't know if what you get is a strong acid, or if you're doing research, magically you find a new strong acid. You will have to figure out it chemically and by its properties, and not based off of just memorization. But just for now, these are a little bit for you, and I'll talk about calculating KPA later. And these are a list of the strong bases. And if you notice the first three on both of them kind of look familiar, don't you think? Because in the first one is halogens and hydrogen, and the next one is, and then the other one for bases is the alkaline metals and OH groups. And the this concept, this idea of just memorizing strong and weak bases would not help you if you were given something that isn't there. But remember, your KPA or your KPB, technically for strong bases, is what dictates whether it's a strong acid or a weak acid, because the equilibrium point for the equilibrium reaction is so far into the right side. Is so far into the product side that it is nearly impossible to get a number that is reasonable for the reactants. Um, and now let's talk about it in terms of acid bases and its conjugate acid and conjugate bases. So a conjugate acid is the compound that takes the proton, that holds on to it. And for this case, it was HCl and water. It is H3O2, so hydronium. So the water takes it. And then the conjugate base is what takes the extra electron. In this case, it would be the Cl. And it most of the time you can just figure out what the conjugate base is by which one lost its H group. And for the compound for uh, HF, which is a weak acid, it has pretty much the same thing. But notice how HF, hydrofluoric acid, is a weak acid, and thus it does not dissociate completely, which means the reaction is reversible. And in this case, which means you could go back and forth between it, and this is what leads to our new chapter on weak acids and weak bases. Weak bases in acid-base equilibrium. And when we continue, these are a list of the new or common weak bases. Hydrofluoric acid and go down the list. But if you notice on the exact opposite of the scale, it is pretty much 1 to 1 what the acids and bases are. Because look, hydrofluoric acid, it's a common weak base, is sodium fluoride. And it continues. And these are common weak bases that do not show OH groups, but OH groups. But this is good because that means that there are weak bases that react differently and have its own system. And they're salts too. They're all salts mostly for the most part. And here's the thing: when we have weak acids, their conjugate bases will most likely be weak bases. Will be basic, and they will change the pH. But a strong acid with their conjugate base will be a neutral acid. And it's a good way of thinking about it because if on the scale of pH you have your weak acid is here, weak acid, and this is 0.714. You know that its conjugate base will be a bit basic, and and that's another good way to judge if you're dealing with a strong acid or a weak acid. And yes, this one's a really brief one. I hope you liked my lightning speed through this topic. And yes, so have fun, good luck, and enjoy.